Let's go. What's up, everybody? Welcome to the Artists of Data Science podcast, the Artists of Data Science happy hour that is. It is Friday, June 24th, 2022. I'm super excited to have all of y'all here. Hopefully you get a chance to tune into the episode that was released today. Finally released the episode that I recorded with Daliana quite a long time ago. So that is finally out. So definitely check that out. Got Daliana Liu on the podcast. We had a great conversation. I can't remember when this was recorded. Must have been like late last year. It's been a while, but check it out. It was a great conversation. Yeah, dude, like just real quick, man, I just want to talk about what's happening in the news today. So, you know, they overturned Roe versus Wade, and I think it's a sad moment in US history for sure. Man, I think like people should have like women especially, they have rights to their body. Like this is kind of just a mess up situation. Like I can't really articulate it, but I know there's so many reasons just going beyond the fact that they're being denied rights to their own body. Right? There's like economic and societal implications of this as well. So I know that most of us are data people, and I was doing some research and came across a video by Vivian, your rich BFF on Instagram is her name, and she just threw out some statistics, and I just kind of want to put this out here to really just maybe help educate us and educate me, and hoping it's educating you guys. But some of the societal implications of this, right? So first, she says that abortion isn't just about women's body; it's also about economic opportunity and money as well, economic security and opportunity. So first, access to abortion increases a woman's probability of graduating college by 72%, right? And not only that, they have shown studies that delaying motherhood by 1 year, so delaying motherhood by 1 year due to access to legal abortions helps increase women's wages by 11%. So there's a lot of implications just beyond that. And I just want to bring that to light. Look, I mean, it's a touchy subject, I know for sure. But if anybody here has any insights or thoughts into this, like, I'd love to hear it. I know it's mostly just men on this panel, but I feel it's kind of our duty to really speak up about this. So hate to put anyone in an uncomfortable situation, but let's go with Ken first.
Yeah, I mean, something that I think is really important is not just the female implications here, but also the economic implications of a decision like this. One of the first books that really got me excited about data science and math and statistics was Freakonomics, which I read quite some time ago. And it's either the first one, Freakonomics, or Freakonomics, that talks about the implications of like abortion in different communities and the like relationship with that to crime, to like economic upward mobility, to other opportunities was pretty fascinating. I wish I had the exact numbers, but that's something I would really recommend reading up on and revisiting, because it isn't just like this is an individual phrase problem. This is something that is a lot larger than that, and it's at least pretty scary on my front to think about how damaging this is, especially for people who do have less access to normal resources. I think something really terrifying to me is bringing up children without that are, for example, going to be brought up in scenarios where they're not going to be loved, where they're resented, where they're put into a really bad position and essentially set up to fail. And when we're creating a structural incentive to fail for a lot of youth, that is not a very good outcome, in my personal opinion. So not to get too political, but I think that there's a lot of statistics and a lot of research done into the broader economic implications of a decision like this that I think should be explored a lot further.
Yeah, Ken, thank you very much, man. Appreciate you sharing some insight there. Yeah, I remember reading that in Freakonomics as well. It's an interesting study that they had done. Look, if anybody else has anything they'd like to speak on this matter, just any point in the conversation, feel free to just drop a comment in the chat section or drop a comment in the live stream or whatever it is that you're watching at. That being said, if anybody has any questions, please do let me know. Or if anybody has any comments, let me know. I'll open it up if anybody wants to chime in here. Vin, anything?
I got to be really careful what I say because not happy. But I mean, my first reaction, good luck enforcing that. You are going to see the first time you try to enforce it, you're going to see what happens. I mean, they're in the F around stage and that's over now. Now they're in the find out stage. You're going to find out. That's where it is for a lot of us. It is, okay, that's it. It's gone from, you're skirting around things and we'll let systems and hierarchies handle that to no, nope, no. That's where I'm at. Nope. Sorry.
Yeah. And thanks so much. All right, guys. So if you guys got any questions on any topic in particular, please do let me know. We're kicking it off. I guess let's go with the I don't know. Let's go with what we've learned this week. How about that? It's been
I've got a
crazy
question if you're
Yes, please go for it, Eric.
Okay, so I am trying to understand data, so like database like design schemas. Like I know there are like different things. And so there's like the star schema, which I guess is the one I'm most familiar with, where you got your fact and your dims. And then there's like Snowflake schema, which apparently doesn't have anything to do with Snowflake. It's probably around before Snowflake, but I don't exactly understand how it's that much different than a star schema, except maybe like a star that has like legs coming off of the points of the star, maybe. I don't know. I read something about an activity schema that Narrator AI uses, and they think it's pretty awesome, but I don't really exactly understand what it is. It just sounds like it's one giant table. So I was just curious, like, what have you all worked with most? And that doesn't necessarily mean you would recommend it. What would you recommend if you were trying to put together, let's say, just like a fairly simple database setup for like a company?
Serge, any input here?
Yeah, I'm not well versed on all the different schemas, to be honest.
What have you experienced most?
I've experienced more of the star, but I don't know all the different alternatives, to be honest. I guess that makes me biased. I don't know. I think the database design should have a lot to do with not only it being like intuitive for those that are going to work with it, because I've seen some things that are done, like pretty much to convolute the whole process and make it what's the word, very, very difficult for people to use. And then the other one is efficiency, with efficiency in mind as well. But there has to be kind of like a balancing act between both. And another one that always gets me is like the naming of things, proper naming conventions and everything, because again, otherwise it becomes a question of usability in the long run. I don't have any more comments beyond that. I don't know. I for a while I became somewhat well versed on this because even though I wasn't like the database administrator, I wasn't a database administrator. It was a part of my job. It was one of the hats I wore in web development. This is a long time ago. So
yeah, I guess I just kind of feel like Mark Freeman a few days ago posted about like data modeling. And so I was like reading through the comments because it was something I was thinking about as well. And I was reading through the comments and there was like one that was like 35 comment long, like thread back and forth. And it was great. It was really interesting. And it was for the most part pretty civil. But it was like these people who like are clearly very well versed in the structuring of a database. And I just feel like as I read, it's like people just like trash the star schema. But I'm like, like if people trash it, I want to know, is it because it's not actually, you know, like that great? Because it sure seems to be pretty pervasive. And, or is it like mostly an academic thing where we're saying we can do so much better than the star schema? But Serge, to your point, like, is it going to be like intuitive for people to use and that sort of thing? So that's what I'm kind of trying to figure out, is like, is the star schema the scapegoat, or is it really just like old and crappy and we need to use something better? I don't know.
Well, there's this again, it's not my area, but I know a data modeler. His name is Francesco Pupini, and he wrote a book with Bill Inman called The Unified Star Schema, and it looks really interesting. It's like it's strange the way it's laid out, but it makes sense. You know, given the kind of problems that happen, you know, like when you're doing SQL and querying all these different tables, like there's forget what he called it, but there is a phenomenon that happens where you, even if you do join the right way, you end up like duplicating your records. And that's why you see all these cases. I've seen them all the time of people ending up putting distinct, even when it's not really needed, just in case, right? There
Okay.
can't be never enough distincts. But I forget what he calls it, but look him up. He has some YouTube videos where he explains the concept and explains the reasoning behind it, and it's to avoid all these pitfalls that happen by using precisely the star schema. But I haven't seen, I don't know the alternatives if they actually counter these problems in any way. But you know, the fact that Bill Inman got involved in drafting this new schema, there might be some something
Cool.
to it.
Found it here. It looks like there's like a Data Vault YouTube summary, so that'll be a good place to start too. Thank you.
Russell, you want to chime in here, and after Russell, maybe Vin. And if anybody that's
Oh, Harpreet's muted, but anybody else, something.
Yeah,
all
I
right.
can.
Well, thank you. I was gonna say let's go to Russell, and then after Russell, maybe Vin. And if anybody has questions in the chat, like just drop a comment, and I'll get to your question.
Okay, thanks, Harpreet. So talking about schemas, I think there's a lot of snobbery about schemas in the industry, and perhaps because star schema is one of the easiest to start with, especially if you've got a low number of data sets. You know, you've got your facts and your dim tables. It's very easy to set up something with, you know, 3 or 4 that all relate back to a single central point for the star schema. However, in my opinion, very often they're not implemented as rigorously as they should be. As Serge was mentioning, you know, you might need to put distincts in more often because the tables haven't been structured and cleaned as well in both ends. And it depends if you allow cross-filtering in both directions across either point of the central star as well. That can give issues. Very often, I'll also add additional nodes onto the outer points of the star, so it'll kind of become a star connected to a star, or it'll be an extra fact table to a single dimension table somewhere. Oh, sorry, the other way around, an additional dimension table to a single fact table. And if you do that a lot, it then migrates into what I think is the snowflake schema, and I think that's in the text that Harpreet's put the link into the chat there. But yeah, I think it's more for snobbery because it's almost the most accessible schema for people first coming into data modeling. It's the first one you get to, so people want to consider themselves above it and move on to something else, even though it might well be the best for some basic databases.
Cool. Kind of what you said there made me think, you're talking about like how sometimes you get into trouble based on the design. So like, I guess the step back from that is, are we identifying our entities, like the process of even getting to the point where we're now going to like lay out what we want this thing to look like once we actually pay money to build it. So I guess maybe understanding that process I would love to understand that process better as well. I'm sure there are frameworks and books all about that as well.
Russell, thank you very much. Anybody got anything to add here, Vin or Ken, on the design of databases? I can honestly say this is something that I've not spent any time thinking about in my career. So it's good to hear all you guys' discussions. Yeah, Ken's like, it's going over my head. Vin, go for it.
I would just say that, so it's optimization. At the lowest level, they're arguing over optimization. And, and Russell kind of nailed it when he talked about relationships and the complexity of the relationships and beginning to understand your schema is really the connection between your categories. And if you think of every column and every table, you're thinking of a different category, supposedly. And some of those categories are related to each other by business logic. Some of them are related to each other by something a little bit more natural, just basic domain knowledge and domain expertise. And the more complex you get down this rabbit hole, the more you start doing performance monitoring and analysis. And then that tells you what schema you actually need. It's not the schema you start out with. It's what about that schema doesn't work. And then you fall in love with one or the other. But remember, there's also a different type. You could do NoSQL and you can do graph. And sometimes having less structure is more optimal. Sometimes it absolutely makes your life a nightmare. And once you get into a certain level of complexity with your relationships between data, that's when you want to start exploring a graph database, because it is so much more elegant, because you're no longer just querying along the lines of data. You're querying along the lines of relationships, and you don't necessarily want to learn about the data. You want to learn about the information contained in the relationships between data. And that's where you begin to evolve into the graph structure. So just always remember that what you start out with, just build a relationship table and then you're good. That's step one. And, they'll tell you to build out this. Most databases have tools where you can map the relationships and everything and get a visualization of it. And that'll give you an idea of how horrible what you're encountering is. So at that point, that you actually put together a database and start creating relationships, it is that visualization after you have about 15 or 20 tables that you start realizing the architecture and why we have all of these different schemas and different types of databases and everything else. So that would be what I would add, is just realize that at the very beginning, it's not that important except to begin to document relationships.
So hearing you guys talk about all this, I know there's probably some people listening, and even myself, where it's damn, is this shit that I should know how to do? As a data scientist, as a someone who's primarily doing machine learning type stuff, is this something that a skill that we should have in our tool belt? Yeah, Vin. Yeah. Awesome. Well, there you go, guys. Nothing for y'all to learn up on. Eric, follow-ups or any questions?
I don't have a qualified answer to your question, Harpreet. I'll just take Vin's head shake. But one thing I will say is I didn't understand even the star schema. I didn't know how tables, I got the idea of how tables are supposed to relate, but I didn't understand the logic behind that until a year ago, when I started working in my job, and I was oh, this is brilliant. Why didn't I think of this before? Because I never needed to, for one thing. But if I would have known about it, if it had even been mentioned during school or something like that, it'd be just it just seems pretty low hanging fruit to say, we're going to think of data in just a little bit of a structure where we're going to have a fact table, a couple of different dimensions, and that's how you're going to join things in ways that make sense, so I don't think it needs to be something go out and build a database yourself. But I think conceptually, even just having a good conceptual knowledge of that would have done me a lot of good.
And Serge, in the comments here, you said that you love graph databases. So real quick, just, Vin also talked about graph databases. So what do you love about graph databases? What have they made easier to do for you?
Well, I think for lots of applications, that could leverage the kind of tools where you're seeing things in terms of nodes rather than in terms of records. You're like things like route optimization. Like for my startup, I use Graph and NoSQL a lot, and my startup had a lot of geospatial data because it was about places and events. So it was very important to know what was near. So it's really good for that kind of application. Um, it's also it really depends what you're working on, like what Vin said. It's not something you can apply to everything, or at least, well, maybe you can, but maybe you shouldn't. So I can't. I'm drawing a blank on, but there's a vast amount of different applications it's useful for. And it's it could do with social networks, like you're analyzing connections between people, or maybe in things like maybe Ken here can tell me if there's something applicable in sports analytics, but I'm sure there is because there's so many relationships between people. Like if you want to ask the question of, you know, the what is it, the 6 degrees of bacon, or what is it, 70? Well, how close is one node to another? That sort of thing. It's really good for that sort of thing. I don't think you can do that as easily with a traditional like DBMS.
And have you heard of the use of these graph databases in sports analytics?
In some sense, yes. I mean, we do a lot of work with like geospatial and positional data. To be perfectly honest, I haven't really worked with too many that like off the top of my head I can think of, but there's definitely applications. It's more about adoption and like what companies, what teams, what organizations are willing to experiment for either efficiency or ease of use.
How does that work? Like you said, geospatial and like positional, locational data. Like, how does that work with sports analytics? Is that like trying to say like if somebody is, I guess, running across a field and they're striking, kicking a football or something like that, or a soccer ball, where does it go? Like, I guess, how do you use that type of data in sports analytics?
Yeah, well, so a lot of it is just the positions of all of the athletes on the court or the pitch or whatever it might be in the position of the ball. And so from that, it's all time series. So you can play out the entire game in a series of points, and you can predict what will happen next in a frame. You're using a lot of like time series predictions to figure out what might happen next, or if there's some instance of injury that might happen in a certain circumstance based on a bunch of the moving parts. So it's a lot of opportunities. You can also get finite events from that time series data, like when someone takes a shot or any of those types of things. So you have a lot of different information that you can like discretize if you really want to. So at the most basic level, you can have all these points and it can be refined into specific actions.
Now I'm curious, like, how does that data even get collected? Is it like through like wearable devices, or is like somebody actually like going through a video reel and saying, "Oh, it was at this position"?
They're not hand doing it. So there's two ways they do it. So one is video. So for each, for example, basketball game, there's a company called Second Spectrum that has their like equipment set up, and it takes like really high quality video of the court, and it maps all the players as they move around. In the NFL, they have trackers, like little chips in their football pads that's tracking the position of all the players like that. So in the future, I expect there will probably be more sensors where you could get things like heart rate, blood sugar, like crazy stuff. I mean, we could do that now, but athlete unions are very much against that because they believe that teams will use that to lobby against the players or in contract negotiations or in things like that, which would be probably a really good thing for the teams, but not a good thing necessarily for the athletes if they're not working super hard. It'd help them improve a bunch, but it would be one thing that could be held against them. So that's generally the way that that information is collected as of now.
Is that stored in like some type of I guess bringing this back to databases, like when you get that data, like is it just like in a database, like a JSON blob, or how's that get sent?
Yeah,
Or does that get ingested?
I've only worked with it in a database format as like a normal like SQL like structured database. I would imagine that the companies that collect it don't store it in that format because it doesn't seem like that would be the most efficient way to keep track of all of it. I would probably have to ask them, which maybe I'll try and do on the podcast one day.
Yeah, that's interesting. Ken, thank you so much. And you recently did something with SAS that was pretty interesting, right? Like using machine learning to get better at swinging in baseball. How's that work?
Honestly, that was sick. So they did this project to teach about data literacy. So essentially they built this batting cage at the SAS campus, and they trained a pose estimation model on, well, they didn't train the pose estimation model. They used a pose estimation model to get embeddings for college baseball swings. And then they built a model that would compare your baseball swing and where like the angle of all of your swing was at each point in the swing to determine how far you were away from a college baseball player's baseball swing. And then based on that, they told you how you could improve your baseball swing through that process. So something I've been talking to a lot of companies about, especially related to sponsorship, is it's really hard to like sell a machine learning product to someone who doesn't know a whole lot about machine learning. And this is a really cool and simple way to show value that machine learning is creating in something that a lot of people understand, which is sports. So you can go in, you hit balls, it tells you what's wrong with your baseball swing, you make those changes, and in general, you hit it harder. So they were using, like, I think it was 10 kids over 6 weeks to document where they started and where they finished. And they didn't have a control group, so I gave them a little flack for that. But the progress that some of these kids were seeing was like really impressive. We're talking about like 15, 20, 30, 100% improvement in exit velocity when hitting the baseball. So if anyone wants to learn more, I made at least what I think to be a very fun video about that.
Yeah, I'll link to that right here in the chat, and it'll also be this in the show notes. Like, it's interesting because you did this with SAS, and that's like, I used SAS back in the days in insurance and when I was in biostats, and it's not something that I typically associate with like machine learning. Did you get a chance to see how these data scientists were building these models or doing their, like, were you like shoulder to shoulder with them, like seeing how they're doing all this stuff in SAS? They look, and if you did, they look just completely different from like a Python workflow.
No, so I mean, honestly, SAS is making a really strong push right now to integrate well with open source. So you can integrate with, I believe, like the majority of their infrastructure with Python or with R. Everything was Dockerized, everything was like put into these confines that people are familiar with and using now. I mean, the way I look at it is it's another platform that lets you use a suite of machine learning tools rather than having to like specifically tweak them on your own. So just like a lot of these other products that are more like out of the box, maybe like a hybrid between like what a data scientist would use and what an analyst would use. That's a little bit more of like a GUI and those types of things. I didn't have hands-on with the product. I was more just there to talk about the use case. But I will say their campus is outrageous. It was one of the coolest places I've been in forever. It was sick. Really, really cool.
Vin, it sounds like you've been there, you've checked it out. So tell me about your experience using SAS, like over the course of your career. I'm sure you've probably seen some crazy things where people are maybe deploying SAS models into production. Like, what does that look like?
So yeah, their campus, unreal. I've given a couple of talks there, and it's massive, and you don't even realize how big it is from some of the conference areas until you walk around, and it's just like, oh my god, this keeps going. It's huge. And my relationship with SAS, I'm not going to say anything because it's if they say if you don't have anything good to say, don't say anything. I have nightmares about SAS. I'll just put it that way. it has its place in the scientific community. It is very useful there. It's like the stats field and economics field go to. But yeah, I don't know why you would do that to yourself. And I'm sorry, please invite me back. But yeah, I can't. I just I can't. Uh,
I
it's
too
hard. It's
have
hard to
nightmares.
use. It's hard to use.
Yeah, I too have nightmares about SAS. That was like the biggest point of friction for me, I guess, in my transition into data science was after having been nothing but a SAS kind of a statistical programmer and statistician for like 5 years, was changing the way I think so I can write in a more general programming language like Python, because SAS is it's different. Like I don't know, I can't even like compare it. But there, luckily, there's a page on the pandas documentation that was Python and pandas for SAS users, and that helped kind of make that transition. But definitely, yeah, definitely don't have fond memories of using SAS and studying for all those SAS exams. If anybody has any questions, please do let me know in the chat or right here in the room. If there are no questions, then damn, it's about to be a short ass happy hour, that's for sure. Costa, go for it. You are muted, Costa. Costa, you're muted. Okay. It's happening.
Thanks. Jeez, man, the last 3 years, everything's like, oh, you're on mute, right? So, question for you guys. Have you guys seen in the tech space, the data science space, I'm talking a mix of like short projects, long projects, 4-day weeks. Have you seen it work? Have you seen it fail? Have you seen it executed at a, I mean, what's your experience with it? Do you think it could work? Do you think it could, I mean, what are the signs of it potentially working and what are the signs of it really struggling? I'm just curious. And do people actually see value in it, right? I'm just wondering what people, I mean, mostly in the States think, because there's different views of it across the world, right? So, yeah.
Let's go to Ken, and then maybe after Ken, we'll hear from Ben. And by the way, if Maria, if you have any questions or anything to add, please do let me know. Ken, go for it.
So out of the gate, I would say with the whole new like work remote movement, there's probably a lot of people that are already working 4-day weeks and are just like, I don't know, like leaving Slack on or doing whatever it might be. I don't think that for any stretch of the imagination really hurts productivity if you're getting your work done. I mean, the nature of our work is largely project focused. And if you're delivering the things that you need to be delivering every week, and if you can do it in 4 days, who cares, right? I mean, if you can do at least for me, I could probably do like 3-4 hours maybe of really good solid work each day. And if, you know, those are the number of hours I'm putting in, and that's all I'm going to get done in that period of time, why should I be in the office, or why should I be working and doing like really subpar work or like work that's detrimental during that time? So I'm a big fan of just saying like, hey, these are the things we have to get done. If you can do it in 4 days, great. If it takes you 5 days, great. But we shouldn't be putting like an hour requirement. It should be based on business need. I don't think that that's a common sentiment among companies themselves, but every company that I've talked to or worked with that had a more flexible schedule, more of like, hey, be here if you need to be here, like don't be here if you don't have anything to do, has, from what I've seen, worked relatively well. I'm sure that there are examples on the opposite side. I mean, Elon Musk is a stark proponent of the complete opposite, and he's done some relatively neat stuff in his lifetime. So I could definitely be off base on this one.
So to add some flavor or some context to that, right? So obviously, you're right, when it's like project-based work and it's kind of time boxed and time limited, those kinds of functions are quite easy that I can say, oh yeah, cool, if you can finish that in 4 days, great, 3 days, great, whatever. But when you're talking about providing a product and providing like a long-term service, for example, you're going to need support, like tech support. You're going to need when your product goes down. You're going to need all these site reliability engineers. Customer, customer success managers. How do you manage all of those moving parts? While I assume what we're going to see in the next 10 years is a general transition to an understanding that 4 days is a normal thing, right? Is that like from an expectation management standpoint as well, right? You're trying to hire the best talent. You're trying to set a competitive difference, right? Where you're saying, okay, we are leaning into the 4-day work week. That's better for you. So come join us because we're an amazing company, right? Where does that factor into it? Because these challenges are not small and they do impact, they impact clients, they impact projects, products. Yeah, so that's kind of the context behind some of it.
Oh, if I may interject. I think at the moment 4 days might be enough, and I wouldn't want it to become a competitive on that end because there becomes a point in which it's not really effective. It's like the joke in that movie. There's something about Mary where there's like 7-minute abs, and they're like, I came up with 6-minute abs, and then like, what if someone comes with 5-minute abs? There comes a point where like you can't really do anything in that amount of time. I mean, it doesn't. You need to be. It needs to be the enough amount of time for the workforce to continue to be productive. So, and that's all relative, like there's startups that have their employees, whether they want to or not, working 16-hour days. And sure, they're getting a lot of work done, but their employees are getting burned out. So, I mean, it's not a sustainable solution in the long run. And they know it, which is why they have so much churn. But I think if an established company cannot work like that, so they can start offering these things, but it's better if there's actually a convention. And as the tools, the technology progresses, and people in a certain field or an entire industry become more productive, if it there's already a standard of 4 days or even 3 days, as it becomes even more. But it's a good thing, I think, in the long run.
Yeah, Kostab, actually, there's a book there's a couple books by this author, Alex Pang. One book he wrote was called Rest, and one book was called Shorter, which is all about like the 4-day work week. He's actually a guest on my podcast as well. I think the episode, if you just go to my podcast and type in Alex Pang, it should come up with work less, get more done type of thing. But yeah, his book lays out just such a good case for the 4-day work week. People are. His whole argument is that more rest leads to more creativity, more productivity. It's all around better. Helps improve work-life balance. But check out the episode. Ken, I see your hands up. Let's go for you.
Yeah, I wanted to. I don't know if it's necessarily playing devil's advocate, but I had a broader question about that. So I think one of the reasons why 4-day work week can become more attainable is through outsourcing. So there's a lot of essentially non-essential, not tasks that we don't need to have on-prem anymore that we can outsource basically all over the world. And is the 4-day work week just squeezing the bag so someone else has to work more hours somewhere else and we're just working less? Or is it something that everyone can actually work less? Obviously, this varies by industry, by the type of roles and whatever that might be, but I feel like that has to be some component of it, doesn't it?
Then let's hear from you. Go for it.
Okay, y'all, time to tell some truths. Y'all don't actually work 40-hour weeks. Come on. Look at me. Look me in the eye. Tell me you work 40 full hours. Come on. Let's be some honesty here. Everybody's already working a 4-day work week. Come on. You just show up for work at 5 days. I love this because data scientists pretend they work 8-hour days. They don't. You spend at least an hour or 2 hours waiting for some blue bar to go across the screen. I call it blue bar time. And it doesn't matter what you do in technology, there is blue bar time where you're waiting for a query to run, you're waiting for something to train, you're waiting for an instance to spin up, you're waiting for, I mean, how much time do we spend waiting for something to happen? It's a ridiculous amount of compiler time. It's just, there's a ton of time that and at one job that I worked at, what we ended up doing was we structured the week so that all those tasks kicked off before the weekend. So we spent really the entire week prepping for long run tasks. And then we would kick it off either Thursday night or Friday night, depending upon how much time it needed to run. And that was it. Like there's nothing else to do. You just wait till those tasks complete. And so you could structure a work week so that you had all those long run things happening, all those things that you had to wait for anyway, especially if you're working with another team or another organization to get you things, giving them Thursday and Friday to handle all of those. And, you come back on Monday and all that stuff's ready for you. And now you're ready to work. It just makes way more sense to admit reality. We don't work 40 hours. None of us do. And then, sort of be smarter about how we schedule all of these tasks and all these deliverables that we will just be sitting there waiting for anyway. And that's what we ended up coming up with. And in another group, I ended up structuring it so that we had people that worked Monday, Tuesday, Wednesday, Thursday. And we had people that worked Thursday, Friday, Saturday, Sunday. And we ended up compressing project timelines because we were working 7 days a week, but everyone was working 4 days. So we were working 4 tens and everyone got 3 days off. They came back Monday, like actually refreshed because you had time off and you had a bunch of people that didn't have kids. Their days off, no one was anywhere they wanted to be. And so, I mean, if you go on vacation for 3 days, people talk about this, like there's no one at Disneyland Monday, Tuesday, and Wednesday, or there's no one going to a particular, movie theater, or any of that. And so from a life standpoint and from a productivity standpoint, you can make these things work, but only if we're honest. So everybody, come on, let's open up and be real. 40 hours? Really?
Let's still go for it.
So yeah, okay, interesting point then. But counter argument to that, right, is how much of our time is like we in software, we're guilty of this, right? We got sick of these long compile times, long everything. We're impatient as anything. Let's be honest, okay? That's our worst flaw, is we're super impatient. That's why we lean to software. That's why none of us in this room stuck to like electronics and mechanical design that takes 3 weeks of fabrication after you design the damn thing, right? So that's why we're working with software. We like quick turnaround. We like CI/CD to just take care of it instantly. Here's the catch though. We start getting to the point where you've got your, as you call it, blue bar time. I'm going to steal that one, by the way. Blue bar time. That's a great quote. I'm going to keep it. You get to a point where your blue bar time is long enough that it's disruptive to your cognitive flow that in order to make that blue bar time efficient, you've got to context switch to something else. You've probably got 4 blue bars running asynchronously at the same time. I find myself doing that all the time just to try and not sit there and wait, compile. I've been in a team where it was one of my first forays into software as a professional, where we had this big monolithic web app, right? And I had hit, I naively did the whole compile and test thing, but there's cheaper, smaller ways of testing the bits that you're working on. And me not knowing that as a grad, just hit compile and test. So I hit compile, and the senior dev next to me was like, "Wait, did you just hit compile on the whole thing?" I'm like, "Yeah." He's like, "All right, so grab a coffee. We've got 25 minutes." And I'm like, "What?" Right. So like we've brought all that time down, like crunch time down, like 15 minutes, 10 minutes, and we find all this time to do other stuff, and we just add cognitive load. So one of two things: either we actually, like you said, automate to the point where you're able to make these long scheduled tasks run, something that you run overnight and come back to, or something that you run over the weekend and come back to. And I did that at my previous workplace, where I'd say, okay, I want to do 10 or 15 runs of training a machine learning model for object detection with different hyperparameters, different kinds of data set mixes. But I don't want to sit here, train one, train another, wait around, train another, right? So I'd schedule it. So I'd actually have 30 runs run overnight, come back in the morning, figure out first task of the day, figure out what worked, what didn't work. And then within the first hour, I would set up 20, 30 experiments, 40 experiments. I go about the rest of my day doing design work, dev work, engineering work to keep that flow. And then the scheduler would just trigger overnight to train, right? So I could get through 30, 40, 50 experiments a day because I was able to optimize that workflow. So maybe if we're able to do that, I agree, we're able to actually, but I don't know. I'm also getting there's a lot of stuff where it's just like, oh, I've got to push this PR up, and then that's got to take GitHub Actions 10 minutes to do something, by which point either I'm twiddling my thumbs for 10 minutes because it's blue bar time, or I'm off doing something else and I've context switched, I'm distracted and I lose focus and flow, right? So there's this weird balance where we want everything to be so instant, but there are physical limitations and we're not able to get it down to that 30 seconds of blue bar time. It is inherently 5 minutes because there's a container image building somewhere on GCP that takes, and needs a GPU connected or something. And it's going to be a 20-minute build. Fine. So I don't know, like in order to, we've either got to cut out the blue bar time or, like you said, automate it to a point where we can do it reliably. So I think if we're going to do that and actually go down to 4-day weeks, we need to structure the kinds of work, and that's going to vary, right? For data scientists, it's one thing. Back-end, front-end software engineers, what about, V&V testers? What about site reliability? All of those things, right? So I see what you mean, but I'm still not sold about how we can execute on it well as a company overall, because there's going to be people that need sporadic across 5 days as opposed to necessarily 4 days and then take a day off entirely. They might be more efficient working 6 days, but working 5.5-hour days, potentially. I don't know what the science is behind that, but I'm literally just tossing up numbers and ideas at this point. Just curious.
Isn't it kind of already like that? But like, I feel like I'll work like whenever, like, if I got to work Saturday morning for a couple hours, I'll get that done. If that's when I feel like I've got an idea and I can execute on it and do something. Yeah, those are excellent points. And like the workflow that you described, I feel like there's a blog in there somewhere. We should unpack that first. But let's go to Vin and see if you have anything to add or riff off of what Kosip's saying, or Ken, Russell, Maria, if anybody has anything, let me know. Those of you guys watching on LinkedIn, on YouTube, if you have any questions, feel free to comment right there in the chat section. I'll be happy to take your question.
Or, Vin, just to tell me that I'm flat out wrong, because
no, you're not wrong. That's why I'm saying we've got that, it's that second structure that I was talking about, where you split people up into two groups, and you have one group work Monday through Thursday and the next group work Thursday through Sunday. And you end up just handing off, so they're working anywhere between 32 and 40 hours a week, because it's like you said, you work, you have these breaks, you have these sporadic stops. And so working more like a 10-hour day makes more sense, because you're not really working 10 hours. And once again, I'm just being honest. Maybe I'm not talking for everyone, but I know I'm talking for everybody, where you have these breaks where, because I'll have 2 hours in the middle of the day to go work out. That's just how I structure the day, where there's time where I'm waiting for something to happen and I just structure it so that I can work out. And you can do that where, like I said, you have 4 and 4. And so where you have to have people and coverage consistent, that's how you end up doing it. And like I said, you end up accelerating project times using that 4 10-hour days versus 5 8-hour days. And you're sort of making a nod towards reality. Whereas the other way around is if you have more consistent work where you can do kind of scheduling where I was talking about, where you're basically having these massive long run tasks. And when you have large models, that's that you have these huge gaps where you kick something off, and yeah, there's tons of other stuff to do, but you can't really do that because you're always staring at the run. You're like, is this, should I stop it now? I mean, like, that's always the thing in your head is like, should I stop this now and do something else? And you don't really have that same anxiety when you have it set up so that it starts off Thursday night and you come back Monday morning and you get to review the results of a very long, very large run. So it just really depends on what type of work you do, how you can structure it, what type of service level agreement that you end up having. It's, you know, it's a balancing act, but you can make it work no matter what.
Ben, thanks so much. Russell, anything to add there? Or if anybody has any questions, please do let me know. Otherwise, we'll begin to wrap it up. Coming in here.
I was just going to say, funnily enough, I've had this conversation with other people in the last couple of days, actually, just talking about, you know, a 4-day working week, a 3-day weekend, and whether the business industry as a whole wanted to maintain a 5-day working week model. And then you could have, as Vin suggested, I think a moment ago, people that worked 4 10-day days, but a group of people did Monday to Thursday, a different group of people did Tuesday to Friday, and you run them like shifts so that the business maintains a 5-day working week, but no single employee works 5 days. That could be a good model to get everybody to experiment with this, you know, a 4-day working week, 3-day weekend philosophy, better life balance. And the cost is really only an additional 2 hours for every day that you work. I think most people would go for that.
Awesome. Russell, thanks so much. I, for one, I'm a huge fan of 4-day work week. I think it's awesome. I think 4 by 8 or 4 by 7 is a great way to work. More importantly, I just feel like you just be able to work whenever you want. Like if Saturday and Sunday don't work for you, then why does it have to be a weekend? Just take it off on Tuesday, Wednesday if that works better, right? Or spread those 2 days out. Yeah. All that to say, I'm just a fan of just getting shit done on my own time. As long as it's within the constraints and confines of the project and it's not delaying anyone, you know, I think we're well beyond what's the industrial age where these rules were established, right? The factory worker kind of mentality. We're not there anymore. It's 2022. All right, y'all, thank you so much for joining. Looks like there's no more questions, no more comments coming in. I do want to give a huge shout out to our sponsor for this episode. It is Z by HP. Get rapid results from the most demanding data sets, train models, and create data visualizations with Z data science laptop and desktop workstations. The Data Science Stack Manager provides convenient access to popular tools and updates them automatically to help you customize your environment on Windows or Ubuntu. You can find out more by going to hp.com/data science. Y'all, thank you so much for joining us today. Appreciate y'all being here. Remember, my friends, you got one life on this planet. Why not try to do something big? Cheers, everyone.